we're going to talk about compound probability. That's the probability of two or more events happening. So that means we're doing at least two experiments. There are two types of compound probability we're going to talk about: independent and dependent. Independent events, they do not affect each other. One experiment does not affect the other. Dependent means that the first event will affect the second event. So let's go over some examples. We're going to first talk about finding probability of independent events. To do this, you're just going to simply multiply the probability of event A happening times the probability of event B happening. So let's do some examples. We're going to find the probability of spinning the spinner and landing on a red, and then flipping a coin and landing on heads. So first, we're going to talk about getting a red. So what's the probability of landing on a red? Well, there's 1, 2, 3, 4 reds out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sections. So that is 4/10, which I could then actually simplify to 2/5. Then I'm going to find the probability of landing on heads. Well, how many choices are there to get heads? 1 out of how many choices total? 2. So all I'm going to do is I'm going to multiply 2/5 times 1/2. Then I'm just going to do top times top, bottom times bottom. However, I can cross cancel and make that a 1 and make that a 1. And then top times top, bottom times bottom, 1/5. So that means if I did this experiment 5 times, I should land on red and get a heads 1 out of 5 times. Find the probability of spinning the spinner twice and landing on blue and then green. So I'm going to start with blue. The probability of landing on blue, there's 2 blue out of 10, so 2/10. That can actually simplify to 1/5. So I'm just going to cross that out and write 1/5. Now I'm going to multiply that by the probability of finding landing on green. Well, there are 3 green out of 10 chances. So now I'm just going to multiply these. Top times top, bottom times bottom. There's no cross canceling I can do, so I'll just do the multiplication. 1 times 3 is 3, and 5 times 10 is 50. So the probability of spinning the spinner twice, landing on blue, and then green would be 3/50. So if I did it 50 times, I should land on that combination 3 of the 50 times I perform that experiment. Okay, I'm going to use the same spinner for this next scenario. Find the probability of spinning the spinner 3 times, landing on a red the first 2 times, and a yellow the 3rd time. So I am going to do red, red, and then yellow. So I'll find the probability of getting a red, and then getting a yellow. Well, looking at that, I have 4 out of 10 chances to get a red. So that's 4/10 times 4/10. And then there's 1 chance to get a yellow. So that would be 1/10. Now, I can simplify 4/10 to become 2/5. So I'm just going to rewrite this as 2/5 times 2/5 times 1/10. So now I'm just going to multiply top times top, bottom times bottom. 2 times 2 is 4. 4 times 1 is 4. 5 times 5 is 25 times 10 is 250. So there's a 4 in 250 chance of me getting a red, and then a yellow. Now we're going to find the probability of randomly drawing a red marble, replacing it, and then drawing a purple marble. So we're going to start with our red marble. How many red marbles are there? 3. Out of how many total marbles? 12. Now I'm going to look at a purple marble. How many purple marbles are there? 5 out of 12. So what I'm going to do is I'm just going to multiply these. Now I do notice that I can simplify the probability of red to get 1/4. So I am going to go ahead and do that. So I have 1/4 times 5/12. So I'm going to do top times top, bottom times bottom. And I'm going to get 5/48. So the probability is 5/48. Now I want us to look at the same scenario, but it's going to be dependent probability. This time we're going to find the probability of randomly drawing a red marble, not replacing it, and then drawing a purple marble. This is a dependent event. The reason why it's a dependent event is because the first event is going to affect the second event. So I'm going to start with probability of drawing a red marble. Well, the probability of drawing a red marble is 3 out of 12. But we're going to assume that that happens. So if that happens, that red marble is now gone. I got a red. The reason why this is important is because now, as I'm looking for the purple, how many purples are there? 5. But how many marbles are there now? There's 11. Okay, it has changed because I took one red marble out. So now the number of total marbles has changed. So that's going to affect the probability of that second event happening. Now I can simplify the probability of a red to 1/4. Then I'll do that times the 5/11. And I'm just going to do top times top, bottom times bottom. And I'm going to get 5/44. So my probability is 5/44. Okay, we're going to do another one with the same scenario. Find the probability of randomly drawing a red marble, not replacing it. Again, that's the key there. And then drawing another red marble. So I'm going to say that I'm going for a red marble, and that's 3 out of 12. Now we're assuming that this happens. So that means that this red marble, or one of the red marbles, goes bye-bye. So now, how many red marbles are there? There's only 2 red marbles out of how many marbles are there total? Now there's only 11 marbles. So notice that my denominator changes because one thing has been removed. The first event affected the second event. Now I can simplify 3/12 to 1/4 and 1/4 times 2/11. You could cross cancel, but just I'm going to not cross cancel this time. I'm just going to simplify at the end. I would do top times top, bottom times bottom, and I would get 2/44. I know I can then simplify that by dividing by 2, and I'm going to get 1/22. So the probability of getting a red both times is 1 out of 22. Okay, so let's do another one. Find the probability of getting a yellow marble, not replacing it, and then drawing a blue marble. We know that because it's not replacing it, this is a dependent event. So the probability of getting a yellow marble, there's 3 yellow marbles. So this is my yellow. Out of 1, 2, 3, 4, 5, 6, 7, 8, 9. Times, for my blue, we're going to assume this turquoise color is a blue. So there's 4 out of, but wait, because we just said we got a yellow, we're assuming that that happened, so we take one of the yellows away. So now there are 8 marbles. So I'm just going to multiply these. I am going to go ahead and simplify these probabilities to make it easier. 3/9 will become 1/3, and 4/8 would become 1/2. So top times top, bottom times bottom, I would get 1/6. There are 3 red Skittles, 6 purple Skittles, 8 yellow Skittles, 2 green Skittles, and 5 orange Skittles. What's the probability that Mrs. Schuler will get a purple Skittle, eat it, and then get a red the next time? So those are the best colors, so that's why. So we're going to start with purple. Okay, with purple, it tells us that there are 6 purple. And how many Skittles is that total? So we have 8 plus 2 is 10. 6 plus 3 is 9, so that's 19. Plus 5 is 24. So 6 out of 24. So we're assuming that I get that that purple Skittle. And so now I have how many Skittles left? 23. So now I want to know what's the probability that I will get a red. Well, there are 3 red out of 23 Skittles total. Now I'm going to go ahead and simplify 6/24 to make it way easier. That would be 1/4 times 3 over 23. So I'm going to do top times top, bottom times bottom, and that's going to be 3 over 4 times 3 is 12, carry that, 8, 9, over 92. So that would be the probability that I would get a purple and then a red. So as a recap, there's 2 types of compound probability. We have the independent events, which is probability of A times the probability of B. Then we have dependent events, which is the probability of A times the probability of B after A happens. This is where your denominator changes on this the second event. I hope this explains compound probability, independent and dependent events.